Now let's take this example and look at it. And we're going to focus on these first 4 problems here to begin with. Find the limit of f as x approaches each of the following. So if we're doing the first one, this is actually how it would be written out. It would say the limit as x approaches 1 of f of x is. Well, let's see. Here's our function. Our function is this blue line right here. And we're talking about the limit as x approaches 1. So we're talking about what's happening in this area of the function, from this dot down to here, because that's what we consider close to the number 1. So how do we do that? Remember from the last time, what we do is we're going to get on the graph somewhere. I'm going to start on the right-hand side, and now I'm going to have to stay on this blue line and move towards x being the number 1. See, x is 1. Well, what y number, what f value are we getting close to as we get there? It looks like we're moving towards f being the number 1, because when I get here, it's an open circle. It's the number 1, isn't it? So first thought is it's approaching the number 1. Let's look at it from the left side. We can't just look at it from one side and make a determination. We have to look at it from both sides. So let's go back and look at it. We'll get on the left side of the graph. And again, we're going to move towards the graph, so we're going to stay on the blue line, and we're moving towards the graph. Again, we're moving towards this open circle, and if we trace back over with our eyes, that's moving toward the number 1. So it looks like the function is approaching the number 1 from both the left and the right. So we're going to conclude that the solution to this problem is the number 1. The limit as x approaches 1 of f of x is the number 1. Now I suggest that you just stop the video for a moment and try to solve this second problem as x approaches 2, and then we'll come back and discuss it. Well, what happens as x approaches 2? So if we look at this function, and let's start off on the right-hand side. So we're over here, and we're moving on the graph. Notice we're moving up this time, but that's okay. And it looks like the function is approaching what number? The number 3. Well, what happens if we get to the left of 2? Here's the x being 2. If we get to the left of that, we're going to be over here, and we're moving up. And notice it's got a black dot. What does the black dot mean? It means that the function stops right there. So the function's getting closer and closer. As we get to the number 2 in the left and right direction, in the x direction, the function from this side is getting close to the number 2. So if we look at it from the right side, the function's approaching the number 3. From the left side, the function's approaching the number 2. So what's the limit? If you go back and look at your definition, we said it is the number. But from the right, it's approaching one number. From the left, it's approaching another number. So the solution for 2, the limit, does not exist. DNE. The limit does not always exist for a particular problem. So 2, the limit doesn't exist. Well, let's look at x approaching 3. Here is our number down here. Here's x equals 3 right here. So if we get on the graph to the right of it and move, we're approaching, looks like right in this area, so it looks like we're approaching the number 1. If we look at it from the other direction, let's pick a different color now, one we haven't used yet maybe. If we get from the left side of it and we come down, we're approaching, it looks like the same place, we're approaching the number 1 again. So we can conclude that the answer here is the number 1 also. So the limit as x approaches 1 is 1. The limit as x approaches 3 is 1. And at 2 it doesn't exist. Now let's stop for a moment and you see if you can determine what the limit is as x approaches the number 4. Okay, same process that we've gone through several times already. We're going to pick a number. We're going to go to the right of it, and we're going to trace back towards the number 4. And it looks like we're approaching the number 2. And then we're going to pick a different color for me, and we're going to go in the other direction. We'll get to the left of the number, and we're going to go. And again, it looks like the function's getting closer to the number 2. So we can conclude from that that the limit as x approaches 4 is 2. So the fourth problem here would look like this. The limit as x approaches 4 is the number 2. Now, these last 4 problems ask for the function value at these particular points. Remember, the function value is what is the function equal to. And let's look in the case of f of x equals 1, the function value is this black dot up here at the top. So the function value is the number 2. At f of 2, when x is 2, the function value is again the number 2. When x is 3, the function value is not a black dot, it's just this blue curve here, which is the number 1. And at 4, there is no blue curve, there is no black dot, so the function value does not exist. And the reason I'm bringing this up is I want you to look at the limits up here, our answers, and the function values. They don't have to always agree. In the case of 1, they are not the same. In the case of 2, they're not the same. In the case of f of 3, they are the same, but 4 they're not. So they don't have to always be the same thing. Just want to be sure you are aware of that.